Now the 4017 decade counter is most commonly defined as a digital circuit that's just essentially what its name states as a counter. It essentially takes an input clock and then using its different output nodes will pulse at a different sequence to create an on-off sequence that is consistent with counting. And I'll explain more of that later. So here is a pin diagram of the 4017 counter. You can see that it has 10 outputs. So it will essentially create a high at each respective output at a different time. So you can use this with an array of LEDs, and if you put them all in order, each LED will turn on in a very sequential manner. So all you need to get this to work really is an input source here, 9 volts, and your clock and your ground. So the clock we already described in the previous slide. You can generate a clock using a simple 555 timer circuit, which you can then put in directly into this. When you input the clock into pin 14, the clock then controls the sequence of the outputs and when they're turned on and when they're turned off. So let's describe that further. So we have a clock that's generated from our 555 timer that looks very similar to this. So if this is the clock, what is our output 1, output 2, output 3, and out 4? So what do those look like in this case? So I'm going to again draw this clock here just so we can make it easier to see what's going on. So at each rising edge of the clock, input will turn on. So this output is low, but then when it gets to this rising edge of the clock, it turns on and then turns off, and will be off until the sequence starts over. So output 2, when the next rising edge hits, will turn on and then turn off and be off until the sequence start over. And if you can see the pattern here, output 3 turns on at the next rising edge, output 4 turns on at the final rising edge. So it essentially counts 1, 2, 3, 4, and so on and so forth.